Please open in your learning workbook to page 128.
Solving quadratic equations has many practical applications. Consider the following. The Wollomombi Falls in Australia have a height of 1,100 feet. A pebble is thrown upward from the top of the falls with an initial velocity of 20 feet per second. The height, h, of the pebble after t seconds is given by the equation h equals negative 16t squared plus 20t plus 1100. How long after the pebble is thrown will it hit the ground? Okay, so there's two things that I would like to share with you before we begin solving this problem. The first is when you see something like h equals, and you're told in the problem that h represents height, then what you need to think is if an object is at a certain height, that's how far it is above the ground. For example, I am approximately 5.5 feet tall. So if I take this marker and I put it on my head and I say, how high is the marker above the ground? You would say 5.5 feet. If I put it on my shoulder, then you might say it's approximately 5 feet off the ground. And then if I took the marker and dropped it and asked what's the height above the ground now, I hope you would say 0 because it's actually on the ground. So what's happening in this problem is that we're asked how long after the pebble is thrown will it hit the ground? What that means is that the height will be 0. So to solve this equation, we replace h with 0. Hit the ground means h equals 0. The second thing I'd like to go over with you before we start the algebra of this problem is sort of a picture of what's happening here. I want you to imagine that you're in Australia and you're standing on top of the waterfall. So here's you. I'm not an artist. And you take a pebble and you throw it up into the air and it splashes down into the water at the bottom of the falls. Let's take a look at what this equation represents. This equation is telling me the relationship between time and height, so that when the pebble is at a particular location in time and space, we can measure the time it takes to get to that spot as well as its height. So if we let the x-axis be the water level, then its height can be measured at various times throughout its journey. So our vertical axis that we're measuring here is h for height. Our horizontal axis that we're measuring here is t for time. And as time goes by, the pebble goes up to its maximum, down, and eventually splashes into the water. Okay, now we're ready for the algebra. We know that hit the ground means h equals 0. So replacing h with 0, we get 0 equals negative 16t squared plus 20t plus 1,100. Interestingly, this is a quadratic equation, and it's in the perfect form for us to solve it using the quadratic formula. All the terms are in descending order, and we have 0 on the other side. So let's label our coefficients. A equals negative 16, B equals 20, C equals 1,100. We're ready now to plug into the quadratic formula. Our variable is t, so we'll start with t. T equals opposite b plus or minus the square root of b squared minus 4ac all over 2a. Okay, we've got our equation. Now all we have to do is plug in and simplify. Let's do it. All right, so we're going to get t equals negative 20, because it says opposite b. b is 20, so opposite b would be negative 20, plus or minus the square root of 20 squared minus 4 times a, which is negative 16, times c, which is 1,100, all divided by 2 times a, which is negative 16. Okay, anytime you write the quadratic formula, you should always write the equal sign, and your fraction bar should go from the equals to the end of the radical. From the equals to the end of the radical. All right, now we're going to begin simplifying. Here's my exponent of 2, so count the hyphens after that. 1, 2. That's even, so that means that we're going to be adding under our radical. So we get t equals negative 20 plus or minus the square root. 20 squared is 400. An even number of hyphens makes a plus. 4 times 16 is 64. And 64 times 1100 is a big number. 64 times 1100 is 70,400. All divided by negative 32. All right, we continue simplifying. So we get t equals negative 20 plus or minus the square root of 70,800, all divided by negative 32. We're now ready to put this in our calculators. We're going to put it in twice. Once for the plus, once for the minus. Okay, so let's go ahead and do that. Let's compute our entire numerator first, and then we can divide the result by the negative 32. Negative 20 plus square root of 70800. Enter. We get 246.0826939. Then divide by negative 32, and we get that t is approximately equal to negative 7.69 seconds, because we're dealing with seconds. All right, now we're going to do this again for the minus part of the plus or minus. So we get negative 20 subtract square root of 70800, enter, which gives us negative 286.0826939. Then divide that by negative 32, and we get t is approximately equal to 8.94 seconds. All right, so we have two answers, but if you've been following along, you know that only one of those answers makes sense. When you throw a pebble up into the air and ask how long will it take to hit the ground, you cannot get a negative time as an answer. That doesn't make any sense. But a positive time does have realistic interpretations. So we cross out the negative 7.69 as an extraneous solution, and we keep only the 8.94 as our final answer for this part of the problem. All right, that brings us to part B. All right, part B says, how long after the pebble is thrown will it be 550 feet above the ground? Okay, let's see if we can solve this. So, the most important part of this sentence is this phrase, 550 feet above the ground. What that's telling me is that h, which measures height above the ground, is 550. H equals 550. Okay, so then this is going to be a very similar exercise to the one we did just a moment ago. Replace h with a number and solve. So h gets replaced with 550, so we have 550 equals negative 16t squared plus 20t plus 1,100. Now, this time we don't have the equal 0 that we desire, so we're going to have to create that condition. So how would we achieve that? This 550 is positive, so to make it a 0, we need to use a negative 550. So we will subtract 550 on the left, we will subtract 550 on the right, and our new equation will say 0 equals negative 16t squared plus 20t plus 550. All right, Now that our quadratic equation is in the correct form, we can identify the coefficients. A equals -16, just like it was before. B equals 20, just like it was before. But now we have a new value of C. C is now 550. All right, let's plug into our quadratic formula. Again, our variable is t, so we start with t equals opposite b plus or minus the square root of b squared minus 4ac all over 2a. All right, so there we go. There's our quadratic formula. Let's plug in the values of a, b, and c so we can start simplifying. All right, so b is 20, so opposite b would be -20, plus or minus the square root of 20 squared minus 4 times a, which is -16, times c, which is now 550, all divided by 2 times -16. All right, so here's the exponent of 2. Let's count the hyphens. 1, 2. That's an even number, so that means that we are going to add under the radical. All right, so then we have t equals -20 plus or minus the square root of 400 plus, all right, so 4 times 16 is 64, and 64 times 550 is 35200, 35200, and then all of that gets divided by -32. So t equals -20 plus or minus the square root of 35600, all divided by -32. And at this point, we're ready to begin putting this in our calculators. We're going to do the entire numerator, hit enter, and then divide that by the denominator. We'll do that twice, once for the plus and once for the minus. All right, so first we're going to do this with the plus. So our numerator is -20 plus square root of 35600, enter. We get 168.67962226. Then divide by -32, and you get -5.27 approximately. T is approximately -5.27. All right, so once again, we've got an extraneous solution. Time cannot be negative. So we know that that is not our answer, and we're going to have to use the minus part of the plus or minus to get our answer to this problem. Let's begin. -20, subtract the square root of 35600, enter. We get -208.67962226. Divide that by -32, and we get the positive time answer, 6.52. T is approximately 6.52 seconds. And that is the answer to this question. So, how long after the pebble is thrown will it be 550 feet above the ground? The answer is 6.52 seconds.